Welcome, welcome.
Hello,
Did you like the
everyone.
music, Elena?
Loved it. I think the selection Jen made was super. I was just dancing.
Yes, I believe the mix of that music with your nice face and with my bad face in the intro was really, really perfect.
Bad face.
Well,
Okay, we'll discuss it after. No.
welcome everybody. Nice to see you, or maybe I don't see you, probably you see us, and welcome to this first workshop about learning Apache Kafka with Python. I'm Francesco, staff developer at Aiven, and today with me, I'm really lucky to have Olena. Olena, do you want to introduce yourself?
I am a developer advocate also working at Aiven. To be here and to see all our guests. And maybe actually, so I'm based in Berlin. Francesco, you're based in a beautiful Italian city.
I'm based in the lovely Verona. Where are you coming from? Please write
Yes,
that
tell
in
us.
the chat.
I would be curious how many people have evenings and how many maybe have mornings or some other time of the day right now. Time zones,
And
they challenge.
also, I believe it's time for maybe dinner for us, lunch for someone else. If you can write also your favorite food that doesn't involve pineapple, please. I will be glad to hear or
I
to
will
see.
share later a beautiful recipe of pizza with some of the fruits.
Okay, I believe it's time to start. And I would like to, first of all, share a little bit of slides to navigate us through what we will see today. Oh, okay, Matt is waiting for Thai food. I'm hungry now. Okay, so what we will do today is we will try to understand what is Apache Kafka and how to work with Python. I believe the other question that I wanted to ask to our audience is how familiar are you with Apache Kafka? We want to know if you are completely new, if you already heard about Kafka and what it is, if you are a pro and you're just here to check our knowledge. In the meantime, let's try to understand what we will see today. We will have a pack agenda, so we will hopefully finish in 1 hour. And first of all, we will understand what is Apache Kafka. It's a beautiful tool, but as of now, we don't really know what it is. And then we will navigate the details on how to create and manage an Apache Kafka cluster. And finally, once we have a cluster up and running, we will check how in Python we can, first of all, connect to our cluster, and then start producing and consuming messages from it. We will use a set of tools, including Kafka and other tools to support our journey, because we wanted to have an experience for you that doesn't require you to install anything locally. Because we all know, at least I know, that my personal laptop is a complete disaster. So every time I try to follow an online training, I end up having to spend a huge amount of time trying to just deinstall or install stuff. We wanted to avoid this pain for you, so we tried to come up with an experience which is all in a browser. I hope everything will work. So should we start, Olena?
I think we should start. And could you tell us what is Apache Kafka?
I believe Sebastian makes a good point. Some people could think that Apache Kafka is like a new name of Franz Kafka. But before that, I believe we set up a page on the Aiven firm that has a lot of the FAQs. So if you have questions, if you are blocked within the workshop that we will deliver later, just go to this page and check out the entire set of steps that you have to go through in order to set up all the environments, and also some frequently asked questions that we managed to find, some errors that you can detect and how to solve them in the meantime.
I already posted the link in the comment section, so you can grab it there, or you can use the QR code over here.
That's perfect. Thanks, Olena. So going back to the question, what is Apache Kafka? It's close to be Franz Kafka. I believe there is some common origins about where the Apache Kafka name was taken off, and the fact that one of the creators was a big fan of Franz Kafka. But the reality is that Apache Kafka is, as it's written in the slide, and I will read against all the laws of having a good presentation, Apache Kafka is an open source distributed event streaming platform. What does it mean? Open source means that Apache Kafka code is public. Anybody can check out the code, can download the code and install it wherever they want, but they can also contribute to the code. So this means that Apache Kafka is not owned by one company, it is owned by everybody. Everybody can check what is in there, can change it in order to customize to their needs if needed, and they can contribute to the progress of the project itself by pushing changes to the upstream project in GitHub. Then it's distributed. What does it mean that it's distributed? It means that whenever you start Apache Kafka server, most of the time you start a cluster of nodes. This means that whenever you need to, for example, scale up because you have a huge amount of data passing by, well, you can just add nodes to the cluster, make the cluster bigger, and it will be able to handle bigger data volumes. But then what is passing by? What is the data that we are storing? Kafka is an event streaming platform, meaning that it handles a continuous flow of information. You will have some sort of messages, some sort of information that are pushed to Kafka, and then Kafka is able in real time or near real time to send this data out to one or more consumers of the information. And at the end, it's a platform, meaning that it does a lot of the heavy lifting about this transition of real-time events, so you don't have to do it. This is the basic of Kafka. Now, should we understand how Kafka works in the back, the details of the components of Apache Kafka? And if you don't know, Olena has a beautiful talk about how to... What was the talk title, Olena?
Beginner's Guide to Apache Kafka. I thought that's very nice title, and it's probably a very useful talk for those of you. And I see that some of our viewers are actually just starting out with Kafka, so beginners. So we can also recommend that talk for them. But I'm also thinking that Francesco, you will explain stuff even better today.
Maybe. Let's try, though. So what are the basics of Apache Kafka? The basic is what we call a topic. A topic is an append-only and immutable data storage. What do I mean by that? Append-only means basically that is like a log file where you can insert data just one after the other. You cannot decide the order of insertion. It's always one record after the other. Immutable means that compared to a database, with Apache Kafka, you don't have the ability of editing an entry that you already recorded. If, for example, you use Kafka to record the purchases in your website, and Olena, let's make the assumption that you purchase some ketchup, I don't know why, from my store. I register you purchasing the ketchup from my store. Then, you go home and you say, okay, I have pasta. I shouldn't put ketchup, so I should cancel my order, right? That is a common thing to do. What I will have to do is, I don't have the capability in Kafka to cancel the order that I stored before. So I will have to record the cancellation as a new event in the same Kafka topic. So in my Kafka topic, yep.
It's like real life. It's like, yeah, I bought the ketchup, and then I talked to Francesco. Francesco said, you don't put ketchup on pasta, which is debatable. And I'm like, if I don't like the ketchup, I can't really change the past and the conversation with Francesco. I can throw away the ketchup or do something else or cancel the event, but it will be a new event going to the topic. Maybe this one, maybe another one.
Yes, exactly. So the beauty of Kafka is that it has this concept of a topic, which is more or less what you can think in a database as a table. But of course, we can store multiple topics in Kafka. And then how do we push data into the topic? Well, in Kafka, there is the concept of a producer, which is an application, a source system that will generate this kind of messages into the topic. And the messages, as we said, will be stored one after the other following a certain order. Probably it will be likely to be the same order as you do the purchases in your website, with some exception that we will not touch today. But usually, once you have one producer write into Kafka, all the messages that have been produced will be produced in order. Then, once we have the data in the topic, and as soon as we have a message in the topic, we can have a consumer reading from it. So as soon as the consumer attaches to Kafka, the consumer will be able to read the messages from the topic exactly in the same order as they are stored in the topic. And now it happens the real-time part. So we say we produce 4 messages, and then a consumer at a certain point wakes up and reads those messages. But the Klaus, where is the center of the universe, by the way? I don't really know. Okay.
Now you know where the center of the universe is because Klaus shares it.
Okay. So the beauty of the streaming happens now. So we said that we produce the 4 messages to the topic, and then a consumer at a certain point in time wakes up and reads the messages. But this is more or less something like, for example, querying a database can give us. So where is the real-time part of Kafka? The real-time is, now we have a new message, the green message, arriving by the producer. And almost immediately, in near real time, the same message flows to the consumer. So the consumer keeps polling from the topic, and Kafka is amazing because it takes something that the producer just pushed to the topic and makes it available to the consumer. So this allows us to do data streaming, allow us to connect, for example, microservices, connect different type of technologies and sync the data between them in near real time. The other beauty of Kafka compared to other kind of tools that are in the same space is that with Kafka, once we consume the data with a consumer, Kafka doesn't delete the data from the topic. This makes the data available to other applications. So for example, let's say that we have our topic with the list of orders, and I have one consumer, which is the delivery person. And the first consumer receives all the messages in the topic. But then I can have other consumers, like, for example, the manager of the inventory or the billing person. And they will also be interested in these messages. With Kafka, we have the ability out of the box to send the same messages to multiple consumers, always keeping the same order, always working in this streaming mode. Whenever the consumer is ready to read information, we are able to push the information to them.
Francesco, we actually, related to consumers, we have a good question in the chat from a person whose nickname is Get Good or Stay Bad, and he asks, from what he has seen is that Apache Flink is recommended to be the consumer. What would you say on this?
It's a long topic.
How much do we have time?
Yes, exactly. So Apache Flink is one of the potential consumers. Apache Flink is basically a tool that allows you to perform data manipulation, data transformation on top of streaming data. So it's a perfect fit to work with Kafka if you need to reshape the data before pushing it to one or more consumers. But there are use cases where, for example, Flink is not needed. if you want to take the data from, for example, an operational database like Postgres and send it to an S3 bucket for long-term storage, actually, you don't need any transformation of the data, because maybe you want just to take the order table and sync the data to S3 and to store all the data for years and years and years in S3. In that case, you don't need Flink at all. You just need Kafka and what is called Kafka Connect, which is a framework to connect various technologies to Kafka in order to create the entire flow. On the other side, let's say, for example, you have the order information in your Postgres database, but you need to filter out some personal data, for example, the address, which shouldn't be stored in S3. In that case, what you want to do is to ingest the data into Kafka or directly in Flink, remove the fields that shouldn't be seen by the consumer, and then pushing the data to the consumer. So any scenario where you need to change a little bit the shape of the messages, or maybe aggregate the messages, or do something with all the messages passing in streaming mode, it's there where you need Apache Flink. Okay, I believe we covered the basics. The next thing is try to be a little bit operational, because this is meant to be a workshop, so we should do something. So the next step is to create an Apache Kafka cluster. As I said before, Apache Kafka is open source. So this means that you can run Apache Kafka by your own, and you can download the code and run it everywhere you want. There is a little problem with that, is that managing Kafka is not the simplest thing in the world. So most of the time, what you may want to do is to rely on a service that runs Kafka for you. And if you're here by accident, you're really lucky, because me and Olena, we work both for Aiven, and by chance, Aiven offers a managed Apache Kafka service. So should we try to create one with Aiven?
Yes, you should.
Okay.
Already.
Let me share with you just 1 second. What is Aiven? Because I shared already the news about we offer Apache Kafka, but we don't offer Kafka only. We offer a huge set of tools, including Kafka, Kafka Connect, which allows you to integrate between other technologies and Kafka. We have Flink, as our friend Get Good or Stay Bad mentioned before, to transform the data on the fly. We have operational databases like Postgres and MySQL, caches like Redis, Cassandra, ClickHouse for data warehousing and huge analytics, M3 for time series databases, OpenSearch for search engines, and Grafana for visualization. We offer those tools within a platform, which makes working with this tool very, very simple, I would say, because you have one API to start Kafka, to backup Kafka, to stop Kafka, and with the same API, you can start, stop, pause Postgres, even if the architecture of those services are completely different and the way that you manage those services are completely different. And then we offer those services across all the major cloud providers. You see here we have Amazon, Google Cloud, DigitalOcean, Azure, and we have also a new model where you can use it within your cloud account with Bring Your Own Cloud. You can deploy them using our console, and we will see this in a second, or with any infrastructure as a code methodology that you like. And you can integrate all the services in our platform with a huge variety of tools, including all the observability tools that you're already using for your other platforms. So now it's time to start creating a Kafka cluster. There is a QR code here. There is a URL. I believe, Olena, you pasted the URL in the chat as well.
Jen was faster than me, I guess.
Okay.
But yeah, it's already there.
Let me
so
copy paste and let me go through the experience with you. So you will be landing in the Aiven console, where you can create an account. You can use sign up with Google, sign up with Microsoft, sign up with GitHub, or like me, you can continue with the email, clicking on continue with the email button. You give your name. I'm called Francesco, and I believe my company knows me really well. You can give an email. I use Francesco workshop Python at aiven.io, and you can use a password. I can tell you my password, maybe not.
You must use a password.
Yes, and then you can click on register with email. Okay, once you click on register with email, you should receive an email and to be able to confirm your account. So I will not show all the emails that I receive in this section. Just give me a second. I'm trying to find the email. Oh,
and to our viewers, follow this, what Francesco is showing. And if you experience some issues, you can also post your stuff in the comments or use that forum link, forum FAQ link, which we had before, so that it will show you a bit more screenshots in case, because I know Francesco is doing stuff very, very fast when it comes to Apache Kafka. In case you miss something, you can revisit it there.
Yep.
And while you're doing it, oh yeah, please go ahead.
I just received the verification email, and it says that my email is confirmed. So I can wait until it shows me to complete my registration. Your experience might vary a little bit here and there. I believe this browser knows a little bit that I'm working with Aiven, but my experience should be as close as your experience as possible. So what I'm saying here is I need to tell my name, which is Francesco, and it's correctly checking that my country is Italy. You can also subscribe for the newsletter, where we share a lot of good information about Aiven, but not only, about what's happening in the open source world and what are the latest trends in the data space. So I strongly suggest to sign up for the newsletter. And once you fix everything, you can click on Done. And you will see the amazing Aiven console. I want to check, do we have people that arrive until the console page as of now? Or was I already too quick to go through all the steps?
Yes, put your message there. And meanwhile, Francesco, maybe you can answer a question which we have in the chat. From an industrial IoT perspective, what are, from your point of view, the advantages of Kafka over MQTT broker clusters like VernaMQ and HiveMQ?
I believe I don't know the exact HiveMQ and VernMQ, the details of those platforms. I would say that Kafka is not a purely queuing system like other tools like RabbitMQ. And trying to use Kafka for exactly substitute RabbitMQ is probably not the right way to use the tool. I would say Kafka is a way to stream the data. It has amazing abilities to understand where you have multiple consumers, has ability to understand when a consumer goes down and what was the offset of that consumer. So if the same consumer pops up in 1 hour, they can start reading exactly from the same location in the topic that they stopped before, guaranteeing the uniqueness of each message. But trying to, use it for the sake of just replacing MQTT services probably has more I wouldn't say it's a seamless transition from one to the other. I would need to check the details of the two tools that you, Klaus, are mentioning, HiveMQ and VernMQ, to understand a little bit better what are the differences between them and Apache Kafka. I hope this answered to your question, Klaus. And I see also from Matt T that in Gmail, sometimes you have to look in old mails to find the confirmation. I hope it doesn't go to spam. If you don't see a confirmation email, also check in the spam. Shouldn't go there. Are we ready to start creating the Kafka cluster, though?
I think we do. So Alekai and Mighty said that they made it, so
let's try the next step.
Yes.
Okay. So as I was showing you before, with Aiven, you can create a huge amount of different services. For the sake of this workshop, we will limit ourselves to Apache Kafka. So you can see that you can create all the services that I've been speaking about before. Now let's click on Apache Kafka. And this will navigate us to a new page where we will define the Kafka service. First of all, let me tell you one thing up front. You basically sign for a free trial that will give you $300 and a month to spend them. So whatever you are doing now, first of all, we will not ask for your credit card. Second thing, since we don't ask for any credit card, we will not bill you anything. So you have this $300 of free credit that you can use to learn one or more tools within the Aiven platform. Let's now talk about Apache Kafka. We can select the version, with 3.5 being the default, 3.4 was the previous one, and I believe 3.6 with tier storage should come out soon, very soon. And tier storage, if you don't know, it's an ability with Kafka, within Kafka, to store the data that is landing in Kafka to a remote storage like S3. So once we select the version, we scroll down and we can select the cloud provider. We can go with Amazon, Google Cloud, Azure, DigitalOcean, UpCloud. Let's stay with Google Cloud. We can select the region and the data center, basically, where we are going to create our cluster. In our case, I can say Google Europe. I would say, oh, there is the Milan area. So I can select the region in Milan. So it's close to where my business is because I'm located in Italy. So it should be good for to minimize the latency. Then I can select the service plan. The service plan gives you an idea of how big your Apache Kafka cluster is. The minimum is a startup plan with 3 nodes in the cluster. And then you can go to business plans, to premium plans as well, which are the biggest. Again, I would suggest to start with a startup plan. For the sake of this workshop, is more than enough. You will see that it costs $270 per month, but you are always part of this free trial, so you will not have to pay a single cent. If you scroll down, you can also give to the service a name. So I can call it, for example, this Kafka-workshop Python. And I can click on Create Service and Start Trial. This will start my 30 days to explore my service. Okay, what's happening here? Well, first of all, Aiven starts the creation of our cluster. We can see this in the deployment status phase. We are building the Kafka cluster for you. It should take a couple of minutes, more or less. And in the meantime, the Aiven console shows you already how to, for example, check the Aiven documentation, the API documentation, the Terraform provider, in order to be able to take you to the next level, to connect to the service or to be able to provide with infrastructure as code. And then allows you to also check, depending on which language you want to use, how to connect to the resource. We will see this in a little bit. The next thing is that it shows you basically the connection URL, so the service URI. This is where our cluster will be reachable with the host name and port. And since we are using a client certificate methodology of authentication, it allows us to download the access key, the access certificate, and the CA certificate that we will use to securely connect to our Kafka cluster. So what I suggest is to click on those little download icons to download the 3 certificates into one specific folder that we later will reuse to connect with Python. So if you click on this download button, save to my downloads, the same for the access certificate and the CA certificate. Perfect. You can also click on skip this step to skip the step-by-step setting up of Kafka and go to the main console overview. You skip again. This set of procedures will ask you to create topic, consume and produce messages, and check the integration. So we can skip all of this because we really want to start talking about Python, right? It's a Python workshop and we are 30 minutes in and we still didn't see any Python code. So we click next, 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 and we click on finish setup. And we should see a page like this, when our service is probably still in building phase. But what we can do now is to prepare the page, or even better, the Gitpod space that we will use to write our Python code or to execute our Python code. So the next step is to, let me share again the slides, to first of all review what are the requirements. The requirements to connect now, since we are using the certificates to connect to Kafka, is first of all to know where the Kafka cluster is. So we need to know the Apache Kafka URI, and we saw that in the console. And then we downloaded the 3 certificates to be able to connect to Kafka. The next stage is to get to what we call the Python notebooks, is a set of pre-built notebooks that allow me and you to see the code and to execute the code and check that it works on Aiven for Apache Kafka. So how do we get the Python notebooks? The notebooks will be used on Gitpod. So if you copy and paste this URL, you should see, and let's do it together. What you should see is something like this. I already logged in GitHub. So what I see is that Gitpod is asking me to create a new workspace. If it's the first, yep.
I just wanted to say, if you missed the link, our viewers, it's also in the chat. So you can get them in the chat.
I went probably too fast.
No, you went good. I missed it.
So what are we doing here? We are basically using Gitpod, which is a way for us to run some code without having to install anything locally. And in the URL that we just pasted in our browser, we said to Gitpod, please use GitHub repository, which contains all the code. So Gitpod will access the code that is stored in a GitHub repository. And if it's the first time that you use Gitpod, it will ask you to authenticate yourself with your GitHub credential. This is because Gitpod doesn't want to store credential. They are relying on the GitHub authentication, and they are relying on basically GitHub to store the credential and to say if a certain user has visibility on a certain repository. I know it's a long set of steps, but all in all, using Gitpod, we basically eliminate any requirements to install Python or install any libraries of Python locally, which could be a huge headache if you have customized environments or even normal laptop like mine. So what we see here, once you logged in, and that might take a couple of minutes because it will ask you GitHub details, and then you will have to answer a few questions on Gitpod to enable your user. But then once you land in the new workspace area, you should see that the repository that we are aiming to use is the Aiven Labs Python Apache Kafka tutorial. The code editor is VS Code, and the standard machine works fine for us. So you can click on Continue, and this will open the workspace. Is anybody with us today until this step?
Yes, put it in the comments if you are following and if you manage to keep up with everything.
Yeah, absolutely. What we
At least-
see here.
Okay,
Sorry?
we do have thumbs ups. So
Okay, we have a thumb up. Sahin, okay, we have a couple of people here. Perfect. So what you see here is, if you are familiar with VS Code, this is VS Code Online. There is no big change. What we will do now is a couple of things. First of all, do you remember the 3 certificates that we downloaded before? Now it's time to use them. You have to find where you download it. And in my case, I have a My Download folder where 1, 2, and 3 are located with also some images of a blog post that I was playing with 1 hour ago. So I can take them and drag them, if the drag and drop works. Yes.
if
No.
you didn't download them at that point of time, you can easily go to the service page. No worries, it's there. Just download them right now.
In the service page, you can always download all of them from here. So let's try it again. Let's go to Gitpod, open my 3 certificates. Well, yes, we are there, and we move them into the SSL certs folder. So you should have an SSL certs folder out of the box, and you should copy the 3 certificates in there. This is basically the folder that contains all the secrets that we need to pass to Kafka to say that we are a trusted producer or consumer. We will see later. But then this is basically almost everything we have to do to connect to Kafka. So where is the Python code, you might ask? Glad that you asked, because we are, again, 37 minutes in and we didn't see a single line of code. If you open the notebooks, we prepared a set of notebooks to guide you through a set of steps, a set of procedures that you can do with Kafka. Let's start by opening the one produce notebook. So, as the title says, this notebook will allow us to produce data to Kafka. So we are going to produce messages to a topic. Let's see what we have to do. First of all, it's asking for a host name and port. Where do you find this information? Again, if you paid attention to what I was saying before, in the Overview tab, you have the host name and port information. So you can copy the host and replace the placeholder that we put there for you, and do the same with the port. And paste the port information in the port. Then you can click the arrow here. One thing to notice, maybe you will not have an arrow, or you will have something, when you click on the arrow, you will have some sort of warning messages telling you that you have to select a kernel. If you click on the select kernel on the top right, you should see install Jupyter notebooks or a Jupyter add-in that basically is going to install in this virtual machine that we are using all the libraries required to run Python notebooks on the machine itself. So I would suggest to click on that. And then once you install all the libraries, you will see a kernel option that allows you to select the Python environments. You can select the Python environments. Don't select the 3.12 because that's a little bit too new for us. Select the 3.10.12 being Python 3 that has global env next to it. This will allow you to use Python 3.10, which is working with all the libraries that we will see in a bit.
And those extra steps, by the way, again, you can find in that FAQ document. Let me actually post it again, just in case someone is a bit lost. And you, Francisco, can continue.
Okay, so let's run. Once we substituted with the hostname and port, let's run it. As you can see, it's installing something on my virtual machine as well. And now it executed. You will see a pop-up of 3 information windows telling you that it's opening 3 ports. Don't worry about those. It's not something that we care as of now. We just set up 2 strings. Now, in order to talk with Kafka, we are going to install Confluent Kafka. This is a library that allows us to talk with Kafka. So let's do the installation. And if you select the correct Python version, it should install it in a matter of seconds. Again, this is where if you select the 3.12, you will see an error because there is no version of the Python Confluent Kafka library available for Python 3.12. But if you use the 3.10.12, it's working. Now, the interesting bit. Finally, we start talking to Kafka. So what do we want to do? We may want to, for example, push a JSON payload. We can just push any kind of data to Kafka. Kafka doesn't really care about what you push in a topic. For the sake of this example, we will try to push a JSON information. And then from the Confluent Kafka library that we just installed, we are going to import the serializing producer. It's a producer that will serialize the JSON message into a string that we will send to Kafka. And this is what we define in this function, JSON serializer. Basically, it's taking the JSON of the message and encoding it in ASCII format. Then we define the configuration. And in the configuration, you should see a lot of things that are already familiar to you. First of all, the Bootstrap service, this hostname and port. Basically, the Bootstrap service is a link to where the servers of Kafka are located. And we are using the hostname and port that we defined in the cell before. And then we are using the SSL protocol, passing the 3 files that we stored in the SSL certs folder. So the 3 certificates. And then what we are saying is that we are going to use this JSON serializer function to serialize both the key and the value that we will pass in the message to Kafka.
I will interrupt you a second. Could you zoom in a bit?
Yes, of course. And I don't need this part, so I can remove it. Is it okay?
Could you do it a bit more?
Yes. So there is a question about a producer in the documentation from Confluent. What is the difference between serializing producer and producer? I would say that the producer, you use the producer if you don't have to reshape the information before passing it to Kafka. In this example, as we will see in a second, we will handle an incoming set of JSON kind of entities, and we will basically encode them to strings. This is why we need a serializer that does the job for us. Okay, so let's run the second step. And at this point, we are just defining how our producer will act. Now, what we want to do is to produce one message with key 1, key ID 1, value ID 1. It's me, Francesco, that wants a pizza margherita. And we want to produce that to a topic called pizzas. Now, if we try to do this step, we should see an error. Why is that? Well, because the pizzas topic doesn't exist in Kafka. So what we can do is go back to the Aiven console, scroll on the left side until we find topics, and we can click on create topics. And we can write here pizzas, all lowercase. I don't need to check the advanced configuration for this workshop, and click on create topic. This will create the topic that we see on screen called pizzas, exactly the name that we had in the Jupyter notebook, and we'll accept the defaults with 1 partition, 2 replications. These are kind of advanced concept that we will maybe cover in a future workshop. Now that we have the topic created, what we can do is we can go back to the Jupyter notebooks and try to produce. So if we run the code block, we should see an amazing 0 here. Basically, the 0 means that it should have succeeded. Can we test it out? Well, if we go back to the topics, we click on the pizza topic, and we click on the messages. First of all, we will have to enable Kafka REST and endpoint, which allows us to browse Kafka topics with REST API calls and with our console. So we click on enable. And once it's enabled, we can select format JSON on the right side and click on fetch messages. Once we click on fetch messages, we will start reading from Kafka, and we will see that our beautiful message with ID 1 as key and the information ID 1 name Francesco Pizza Margherita as value has been populated in the Kafka topic. Beautiful, right?
Totally. Who
Yes.
doesn't like pizza margarita? I'm actually getting hungry. So
Yes, exactly. It's almost dinner time. Okay, let's do one step more. We produce the data. Let's try to consume the data. And here we see a little trick, which is really, really cool with Jupyter notebooks. By the way, anybody arrive until this point?
oh, maybe
Yep.
that he missed changing the format to JSON. Oh, but he figured it out. That's cool. Could you also write if you're still like if you manage to follow till the step where Francesco is? So let me know. And so our record right now went into the topic.
Yes.
And we can now consume it as many times as we want for many different applications, those consumers. I usually mention those like small robots, and then they kind of take the data, read the data again and again from the topic.
Okay.
Yeah.
Should we do the trick on Jupyter notebooks? Okay, I click on consume to consume, and it opens up next to the one producer. Now, the little trick that makes the magic is that you can click and hold the mouse on to consume and place it on the right side. Why this will be useful? Because it allows us to check both the producer and the consumer at the same time. So if you check the consume side, on the prerequisite, we will always have to substitute hostname and port. So let's scroll the producer to the top and copy hostname and port from there and paste it in the consumer. And then we can run the first cell of the consumer, selecting always Python 3.10.12. Always the same 3 messages. Okay. We install Confluent Kafka as we did with the producer. It's already there. And for the consumer, we are doing something similar. So instead of this, a serializing producer, we are defining a deserializing consumer. We are doing kind of the opposite here. I believe the naming should be deserializer instead of JSON serializer.
We have one message in the chat from Tips who asked to wait a moment. Maybe we can wait for a moment so that Tips can catch up. And we have another question from Zahin about the custom serializer. And do we use custom serializer in this example because of the emoticons provided in the message?
I believe that it's not due to that. I believe it's due to the fact that I'm defining this is not a string. This is an object in Python. On the other side, Kafka expects a random blob of data. So we have to transform this kind of object into a string. This is why we are using this serializer. Okay, so on the consumer side, the setting is almost equivalent to the producer. We are passing the bootstrap service, we are passing the security protocol and the 3 certificates, and we are using this JSON serializer or deserializer, as it should be, in order to deserialize the data. So we define the consumer, and it's good. And now it's time to start reading from the pizzas topic. So what we do is while true loop. So we have a running true, and we always loop and check if there is data in Kafka. And we will do that by polling Kafka with a timeout of 1 second, but we are continuously polling Kafka and retrieving data. If there is a message, if we find that there are no errors during parsing the message with our deserializer, we will print in the output the key and value together with the partition and the offset. Basically, internal details about how Kafka stores the data together with our key and our value. So let's try to run this section. And what we would expect is, first of all, to see the pizza margherita that we already sent. But this is not happening. And even more, something weird is that our consumer keeps spinning without reading any data. So the consumer keeps spinning because we are within a always true loop, because our variable running is always equal to true, and while running will always result in something true. So we are continuously polling from Kafka. And this is what we want, because we want, as soon as a message lands in Kafka, to read it correctly. But then we don't see our first message. Why is that? Well, it's because by default, when you attach as a consumer to a Kafka topic, if you don't specify anything, you will start reading from the point in time that you attach to the Kafka topic. You don't go back in history. There is a special setting to do that, but we didn't use that. So we accepted the default. We are starting our reading from now. So we couldn't see the message about Francesco ordering pizza margherita that we posted before. But how can we check that our streaming data pipeline works? Well, we could produce more messages. We can produce a message for Adele ordering a pizza Hawaii. It's not what I suggest. And another message from Mark ordering a pizza with chocolate. So now, as soon as we click on the run on the left, we should see them on the right, correct? Let's try our luck. Oh, looks like it's working. So our streaming data pipeline works. As soon as I send messages on the producer, I receive them on the consumer. This is the beauty of Kafka. Allows you to, in real time, stream the data from one or more producer to one or more consumer. If I do this again, I see the same messages appearing another time because I push the same messages again. I believe we covered the basics of Kafka, and I hope we had some people following until this step. If you did that, please let us know in the chat. I will be really amazed to see that someone else, that is working for someone else as well, apart from me. We are almost at the hour, and we don't want to have you sitting on a desk. Is it a desk? On a chair, probably, for long. What you can do is we prepared also other Python notebooks that you can use to understand how to use partitions, how to consume from different partitions, how to have multiple consumers reading from the same topic. And also, if you want to explore what we talked about before, Apache Flink, how to handle these beautiful pizza messages with Apache Flink. I want to conclude with understanding what we learned today, which is what is Apache Kafka, how to create Apache Kafka cluster, a little bit of Python to understand how to securely connect, to produce and to consume messages. And also, I want to please hear your feedback about our performance in this workshop. We hope you learned something, but it's always good to hear feedback about what you think about this workshop, and let us know if we can improve in any details. I want to leave you with a little bit more information. The first thing is Aiven Developer Center. Olena, can you talk a little bit about Aiven Developer Center?
Oh, we have an amazing Aiven Developer Center. You will find there a lot of different information on different topics, not only Python, because I love JavaScript a bit more, and Java is amazing. And we also have stuff about other technologies like Postgres or ClickHouse. That's one of the ones I really enjoy working with. So definitely check Aiven Developer Center. You will learn a lot. There is a lot of materials written by different members of our team, and not only.
Then we have Aiven Community Forum, where you can ask questions and reply to your peers, or check how to do something, or ask for suggestions. If you're in for another workshop, in 2 weeks, I believe, we will have a data persistence 101 from our colleague Sebi talking about Spring Boot and MySQL. And then if you didn't subscribe to the Aiven newsletter, you have still a chance to do so following the link. All the links are available in the chat. And I believe there was another question from dev internals talking about the high load, the messages. Let me just check 1 second. The messages behind count of the leg is increasing constantly, and we tune the consumer settings such as max poll, disable auto commit, etc. Okay, so what dev internals is asking is, under high load, there are a number of parameters that you can tune in order to reduce the lag. Basically, the lag is where you produce a lot of messages, and your consumer are not fast enough to follow the number of messages that have been produced. So they start being a little bit late. They are not analyzing the data that is published in real time, because they are still busy analyzing the data that was published 2 minutes ago. In that case, there are a number of parameters that you can tune. But I believe giving general advice on how to tune max poll, disable auto commit, or talking about partitions, talking about consumer groups and stuff like this, it's really depends really on the specific use case. Because, for example, one option when you have a lot of messages is to partition your topic. So to create within the same topic multiple flows of information. If you have those multiple partitions, you can create multiple consumers that are part of the same application. So they will share the load. Each of them will be assigned only to a subset of the partition and will start reading only from a subset of partitions. So I would say, if you have a high load of messages, a lot of problems, I believe, should be solved in how you design your topics in your partition and how you divide your messages across partition. And then if you cannot do that, then really it's depending on the situation and what are your settings. I don't think there are overall global advice on how you set auto commit on max poll. I hope that dev internals, this is okay for your question. If you have more questions, just reach out to in the Aiven forums and we will be super happy to help. Saying that, if there are no more questions, or if you don't have anything else to share with us, or I hope, by the way, that you reach all the stages until you consume the messages, I believe we are done for today, Yelena.
I think so. It was great session, I believe.
Well, thanks everybody that was live today. I hope you enjoyed. Just remember to please give us feedback. It will be really helpful for us. Check the other resources that we pasted, and tune in for the following workshop from Sebi in 2 weeks about data persistence with Spring Boot and MySQL. Saying that, it's dinner time for me, and I believe also for you. Thanks everyone for being here, and seeing you soon. Bye-bye.
Thank you very much.